Chandrayaan-3 is the third moon mission by India's space agency ISRO. The goal is to place a lander and rover on the lunar surface and operate them for roughly 1 lunar day, or 14 Earth days. The small rover, which weighs just 26 kilograms, 57 pounds, will fly to the moon inside the lander. Both vehicles are equipped with science instruments to study the surface. The Chandrayaan-3 lander and rover are similar in design to those from the Chandrayaan-2 mission. In September 2019, the Chandrayaan-2 Vikram lander successfully lowered itself to within 5 kilometers, 3 miles, of the moon, entering a fine braking mode that would have placed it gently on the lunar surface. Like its successor, Chandrayaan-2 was targeting the moon's south polar region, where ice has been found inside permanently shadowed craters. Unfortunately, a software glitch caused Vikram to veer off course, and ISRO officials lost contact with the spacecraft. NASA's Lunar Reconnaissance Orbiter later found debris from the vehicle scattered about 750 meters, a half-mile, from the intended landing area. The mission was not a total loss. Chandrayaan-2 also included an orbiter that continues to study the moon from above. Among other scientific functions, the orbiter is equipped to scan for water ice. Having figured out what doomed the Vikram lander, ISRO says they have upgraded the lander's software and performed numerous tests to ensure that Chandrayaan-3 goes according to plan. Chandrayaan-3 does not include an orbiter, although the propulsion module that will carry the lander to lunar orbit is equipped with a science instrument that will observe Earth as if it were an exoplanet, providing data for future exoplanet studies. Chandrayaan-3 is an ISRO, Indian Space Research Organization, mission with the primary objective of putting a lander and rover in the highlands near the south pole of the moon in the August 2023 timeframe and demonstrating end-to-end landing and roving capabilities. It will also make a number of scientific measurements on the surface and from orbit. It comprises a lander, rover and a propulsion module. The lander, rover will be similar to the Vikram rover on Chandrayaan-2, with improvements to help ensure a safe landing. It will be carried to lunar orbit by the propulsion module, which will remain in orbit around the moon and act as a communications relay satellite. Spacecraft and subsystems. The propulsion module is a box-like structure, modified I3K structure, with one large solar panel mounted on one side and a large cylinder on top, the intermodule adapter cone, that acts as a mounting structure for the lander. The main thruster nozzle is on the bottom. It has a mass of 2,145.01 kilograms, of which 1696.39 kilograms is propellant for the MMH plus MON3 bipropellant propulsion system. It can generate 738 W power. Communications is by S-band and attitude sensors include a star sensor, sun sensor, an inertial reference unit and accelerometer package, IRAP. The lander is also generally box-shaped, 200 by 200 by 116.6 centimeters, with 4 landing legs and 4 landing thrusters. It has a mass of 1749.86 kilograms, including 26 kilograms for the rover, and can generate 738 W using side-mounted solar panels. The lander has a number of sensors to ensure a safe touchdown, including an accelerometer, altimeters, car band and laser, Doppler velocimeter, star sensors, inclinometer, touchdown sensor, and a suite of cameras for hazard avoidance and positional knowledge. Reaction wheels are used for attitude control, and propulsion is provided by IMMH and MON-3 bipropellant system with 4 800N throttleable engines and 858N throttleable engines. An X-band antenna is used for communications. The lander carries the rover in a compartment with a ramp for deployment onto the surface. The rover is a rectangular chassis, 91.7 by 75.0 by 39.7 centimeters in size, mounted on a 6-wheel rocker bogie wheel drive assembly. It has navigation cameras and a solar panel that can generate 50 W. It communicates directly with the lander via RX/TX antennas. The lander will carry an instrument called Chandra's Surface Thermophysical Experiment, CHASE, to measure surface thermal properties, the Instrument for Lunar Seismic Activity, ILSA, to measure seismicity around the landing site, the radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, RAMBA, to study the gas and plasma environment, and a passive laser retroreflector array provided by NASA for lunar ranging studies. The rover will carry 2 instruments to study the local surface elemental composition, an alpha particle X-ray spectrometer, APXS, and laser-induced breakdown spectroscope, LIBS. The propulsion module, orbiter, will carry one experiment called the spectropolarimetry of habitable planet Earth, SHAPE, to study Earth from lunar orbit. Mission profile. The mission is currently scheduled to launch on the 14th of July 2023 at 9:05 UT, 2:35 PM India Standard Time, with the possibility to launch as late as the 19th of July, on AGS-LV Mark III, LVM-3, heavy lift launch vehicle from Satish Dhawan Space Center in Sriharikota, India. It will place Chandrayaan-3 into an approximately 170 by 36,500 km elliptic parking orbit. The propulsion module will bring the lander, rover will into a 100 km circular polar lunar orbit and separate. The lander will then touch down with the rover in the south polar region of the Moon, near 69.37 S, 32.35 E for the scheduled launch time. Touchdown is expected to occur near the end of August. Touchdown velocity is planned to be less than 2 meters per second vertical and 0.5 meters per second horizontal. The propulsion module, communications relay satellite, will remain in lunar orbit to enable communications with Earth.